All right, friends, it's your boy, Mr. Shagney, coming at you with Unit 3, Lesson 11, Scales Without Units. It says, let's explore a different way to express scales. So the first activity is called 1 to 100. It says a map of a park says that its scale is 1 to 100. What do you think that means? So it means distances in the park are 100 times bigger than corresponding distances on the map. So distances in the park are 100 times bigger than the corresponding distances on the map. Yesterday we talked about if I give you a scale, right, you already know the scale factor. This means 1 times 100 equals 100, right? So we know the scale factor is 100, and we proved that yesterday with our second activity that tells you your scale factor. Another thing you can look at this and say is that 1 unit on the map represents 100 units of distance in the park. Okay? Question 2 says, give an example of how the scale could tell us about measurements in the park. So, given a scale, if a path is 6 inches long on the map, then we could tell the path is 600 inches long. So we just take our first measurement, multiply it by 100 to get our second measurement. We could use the scale to tell us about the size of the park. Okay, so that's our first activity. So we're really trying to understand what a scale tells us. It tells us that there is a relationship between the two numbers, and we can find our scale factor by looking at what times this number gives you the second number. And then we're going to go to our next activity called the Apollo Lunar Module. So it says your teacher will give you a drawing of the Apollo Lunar Module. It is drawn to a scale of 1 to 50. 1 to 50. So it says the legs of the spacecraft are its landing gear. Use a drawing to estimate the actual length of each leg on the sides. Write your answer to the nearest 10 centimeters. Explain or show your reasoning. Right? So if I know that this is a scale of 1 to 50 and they want me to do centimeters, I'm going to measure in centimeters. So I'm going to say 1 centimeter to 50 centimeters would be the scale that I want to use here. 1 centimeter to 50 because I'm going to measure in centimeters. This is a drawing that you're going to get, and we're going to measure the leg. So in centimeters, we're going to measure the leg. So I'm going to start here, and about here, right? So then that's about 7, right? So about 7 centimeters. And it could be more, right? 7 centimeters. I know some of you are going to be like, oh, that's too little. But, I mean, if we wanted to say 7, 7's a good number. 8's too much. 7, let's see. From there, it could be 7.5. So let's do 7.5 just to be a little bit more exact. So what I'm going to do is I'm going to take 7.5 centimeters, right? And remember that for every 1 centimeter I just measured, it actually represents 50. So what I'm going to do here is I am going to times this by 50, right? So I'm going to do 50 times 7.5, 0, 25, 0, 7, or no, 0, 35, 0, 5, 7, 3. So I get 37 and a half. Yeah.
Okay, so I'm gonna go do 500.
So 37 and a half.
Check with you first.
So 37 and, or no, it's not even 37, 375. So we have 375 centimeters. Now, if I wanted to convert this to meters, right, I know that it takes 100 centimeters to equal 1 meter. So I would just divide this by 100. So if I'm dividing that by 100, 375 divided by 100 would be the same number, but we're just moving our decimal back 2 times. So 3 and 75 meters tall. So I made some mistakes there, so I want to make sure I clarify a little bit here. So the first thing I did was I measured. I found that this was 7.5 centimeters, and then I know that 1 centimeter on my scale equals actually 50, so that I multiplied by 50. Then I made a mistake here when I multiplied, so I got this and I moved the decimal too many times, so it's supposed to be moved once, and I apologize for that. So I did the math right, 375 centimeters. If I'm converting from centimeters to meters, and I want to know how many meters tall something is, I'm just going to go ahead and divide by 100. So I know that it's 375 centimeters, or 3 and 7,500 meters tall. Now it says, use the drawing to estimate the actual height of the lunar model to the nearest 10 centimeters. Show your reasoning. So nearest 10, so I'm going to start down here. Nearest 10. So if I include this, I could say 17 centimeters. So if I said 17 centimeters there, so I have 17 centimeters. Remember that for every 1 centimeter I have, that represents actually 50 on the real thing. So 50 centimeters. So then I have 50 times 17. Sorry, that X is in the wrong place. 0, 35, add a 0, 0, 5, 0, 5, 8. Right, so 850 centimeters. And if I want to convert that to meters, I divide by 100. And so that's really just 8.5 meters tall. This one says Neil Armstrong was 71 inches tall when he went to the surface of the moon in the Apollo lunar module. How tall would he be if he were drawn with his height to the scale? Show your reasoning. So we're going to assume that the scale now represents 1 inch to 50 inches. So we're going to take 71, and then we're going to divide that by 50. So 50 goes into 71 one time. Subtract 50. 1, 2. Add a placeholder. 210. 50 into 210 is 4. So that's 200. Left with 10. Bring down a 0. 15, and that is 2. So he would be 1 42 inches tall. Down here it says, sorry. Sketch a stick figure to represent yourself standing next to the Apollo lunar module. Make sure the height of your stick figure is to scale. So show how you determine the height on your drawing. So what we're going to do here is, so I am this, right, 5 feet 11 inches. If I want to convert feet to inches, I know that there are 12 inches in a foot, so this is really 60 plus 11, which is 71. So I'm the same height as Neil Armstrong. Who knew, right? So 71 inches divided by 50. Right, I'm going to do that first. That is the same answer I got up there, which was 1. decimal point 4. Two. So, if I want to measure this with actual centimeters so that it's pretty close, because this is going to be hard to measure, what I can do is convert inches to centimeters. I know that 1 inch equals 2 5/4 centimeters. So what I'm going to do is I'm going to multiply 1 42/100 by 2 54/100. It's 8, 16, 5, 0, 10, 21, 5, 6, 7. Add 2 zeros. 4, 8, 2, 8, 6, 10, 16, 3. We'll move it 4 times. 1, 2, 3, 4. So it's about 3 6/10. So that's how about it's going to be accurate as I can. So I'm going to measure 3 6/10 centimeters. Here, 3 6/10 would be there. Right, so that's the length of my body. It says sketch a stick figure, so I'm gonna make my head here because it needs to be a part of that. And then there's my arms, there's my legs, and I made my little stick figure, right? And this line represents 3 6/10 around it because I had to. So that is what we're doing in the second problem. I apologize for some of the mistakes I made there, but you know, it happens. Like calculations, we all make mistakes. So can't feel fault for that. I actually went back and explained myself and checked my work. So the last activity we have is called same drawing, different scales. So it says a rectangular parking lot is 120 feet long and 75 feet wide, right? So the actual parking lot is that big. Randy made a scale drawing of the parking lot at a scale of 1 inch to 15 feet. That means for every 1 inch on her ruler, it actually represented 15 feet of both of those lengths. The drawing she produced is 8 inches by 5 inches, right? David Farrell made another scale drawing of the parking lot at a scale of 1 to 180. The drawing he produced is also 8 inches by 5 inches. Right? Explain or show how each scale would produce an 8 by 5 inch drawing. So, my question to you is this, right? So 1 to 1, right? That's not changing, but I want to know if there's a relationship here. So I'm going to first look at that. 15 into 180. That's 1 time. I'm just going to check to see if there's a relationship because I just want to see 12. Right? So times 12 will give me that. So I'm thinking, I know 1 inch, right, is equal, like 1 inch, it takes 12 inches to make a foot. So these right here might represent inches. So that's my inkling, right? So if those represent inches, these should be equivalent in that respect, right? So they should be equivalent. So what we're going to do here is we're going to show how each one of these people could produce this. So I'm going to go to Randy. What I'm going to do is I'm going to take the side length of 120 and I'm going to divide that by 15. If that gives me 8, that shows me how she got her number. So 15 goes into 120. Let's check 8 times. So I'm going to show multiplication here. 40. Looks like 120 on the money, right? So that's her first one, and then she has 75 divided by 15. And this is Randy's work, right? Randy, I'm doing work for Randy. 15 into that should be 5 times. I'm going to check that work. 25, 75. So that's how Randy got her numbers. Now, David made a different scale, right? So you can't just, you know, divide those because that's not gonna work out. So we're gonna have to do something first. We're actually gonna convert these first to inches to see if that's what David did. So I'm gonna take 120 and I'm gonna multiply it by 12 because there are 12 inches in a foot. And if I really know 12 times 12, I know that's 144, and I can add a 0 here, right? So that's just thinking And then I'm gonna take my second number, 75 times 12. This number I might have to actually do the math for. I can't, don't want it to overstep. And then 5, 7, 0, 10, 9. So we have 14, 40, and 900 inches. Now with these numbers, we're going to divide them by 180 to see if they give us the measurements we're looking for. So 1440 divided by 180, our little nice getting rid of that 0, so 18 into 144. Well, I'm going to check 8. 18 times 8, 64. 8, 144. So that is that. And then I'm going to take 900 divided by 180. And I'm going to think about it this way, 18 into 90. So I'm thinking about it this way. So I know 9 goes into 90 about 10 times. 9 doubled is 18. And so I would say that 18 into 90 would be half of 9 into 90, which would be 5, and that should give us our second number. I'm going to check 18 times 5, 40, 90. So how they got this work, right? So their scales that they used are equivalent scales, and they're equivalent because this one says 1 inch to 15 feet. So she just said 1 inch represents 15 feet, so you measure it, you get 8 by 5. This one, both of them are in inches. There's no scale on it, but that's basically what they said, is that when there's no scale, both of those numbers represent the same unit. So I figured out that between 15 and 180, there's a scale factor of 12. And I know that from, measuring inches to feet, you need 12 to make 1 foot. So that's kind of how I got there. The second one says, make another scale drawing of the same parking lot at a scale of 1 inch to 20 feet. Be prepared to explain your reasoning. So this one is going to be larger scale, so I kind of want to jump down here to this. So it says, express a scale of 1 inch to 20 feet as a scale without units. So what this means is I want this to be 1 inch, and I want this to also be in inches. So I really want it to be 1 without the units here. So I want to change this to 1, 2, what is 20 times 12? Well, no, 12 times 2 is 24, and add a 0. So 1 to 240 is a scale without units that is equivalent to this, because both of these numbers do have the same unit, but it's just not there. And so it's just trying to get you to see that this is equivalent to that, because it's inches and that's feet. So if I were to divide this by 12, I would get 20, and that's kind of how that would work. What I'm going to do is I'm going to get some graph paper to draw my next drawing. So just give me a second, because I forgot to pick that out. So graph paper. So I apologize for this delay in the video. So here's my graph paper. It says 1 inch to 20 feet. So remember, we're doing the model up here. So 20 goes into 120. So we're gonna first do some math. 120 divided by 20. 6 times. So I need 6 inches for the length of this. Measure 6 inches. Then I need to take 75, divide that by 20. 20 goes into this 3 times, it's 60. 15, add a decimal, 150, 20 into 150 is, well, 2 into 15 is 7, so 7 times 140, 3 and 7/500 inches. Now this one might be a little hard for some of us, so we're gonna measure up to 3 inches, right? So this is 3 inches. And remember that there are, I'm going to count how many tick marks there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 here. And what we know is we have more than 1/4. This is a fourth, right? A fourth plus a fourth makes a half. And our next line that's long would be 3/4 or 75 hundredths. So that's as far as we're going up. So I'm going to take this across. And the great thing is I use graph paper here to kind of help guide me. That's right on the money, right? I knew that that would work out. So this is the scale drawing that you'd end up making. This is 6 inches by 3.5 inches. And so that's what we're looking at today in class. I can't wait to see you.